We're back. This done. I'm not gonna throw it. I'm gonna set it lightly down. I got a new computer that's working from Lake County Schools. Thank you. And which means we're back, and I've got my notes available to me to be able to pass along to you. So again, we're back for a little more math, a little more fun times going on here. While we were gone, I have attained another math championship belt. I'm just saying, I was just the Algebra 1 champ. Now we're going for middle school math champ. I've got a feeling we're going to find some more belts pretty soon. I'm just saying, because, you know, the champ right here. Anyway, of course, it wouldn't be a math day unless we were... Don't forget about Dre, guys. Just don't forget. You don't forget. Time to open up some stuff, because we need to do something. We got to get back on this. What do we got here? We got a little DC figurine. Who do we got? Oh, Green Lantern. Ryan Reynolds' most awful, awful movie ever. Just kidding. But yeah, seriously, it was bad. You can go set up here by Max Scherzer. Sweet. That's gone. What else? Oh, we got Trolls. Trolls just came out. So we got a clip of some sort. What we got? See? Oh, we've got Delta Dawn. I got a feeling this is the country one. Pretty sure. Feels right. You can sit up here by Monty Python and the Holy Grail, because of course. And a baseball player too. And remember, if we find an Astro player, we throw it away because we're not cheaters here. Oh no, we're good. Tony Bellinger, we're good. He's a good player. We can like him. All right. You can sit up here. We're good. Look at that. Things are running right by. Disney pins, of course. We got a little Maleficent head. Just a little scary. Stitch, hanging out for today. The Jolly Roger. Little Peter Pan action. Got some Disney pins. I guess still missing the Disney life, but you know what? We're doing what we can. Staying safe, staying away from people as much as possible. Some quotes, of course. Can't go on without quotes of the day. From yesterday, which is my birthday. I'm getting old. My decision-making skills closely resemble those of a squirrel when crossing the street. It's probably not the best, but you know, it's okay. And today's quote of the day. Do you ever forget to hide your expressions for a minute, and then you're like, I didn't mean to make that face out loud? It might have happened to me in a meeting earlier today. All right. So we got quotes done. We got some stuff opened up. Clearly showing off that I'm now not just the Algebra 1 champ, but the middle school math champion of the world. Let's go. I think it's time to do a little bit of math. Let's go. All right now, Branch, Poppy, pay attention. This is going to be on the quiz. Here we are, Pre-Algebra guys. Today, doing a little bit of a review over irrational numbers. We're going to look at estimating and then comparing irrational numbers. Okay? So to estimate, we've got to figure out an approximate value. Because remember, irrational numbers means we can't, or we don't have a ratio of two integers that will form the number. For example, the square root of 2. That is not a rational number. Okay? We can't come up with a nice fraction to be able to express it, but we can approximate it. We won't get the exact value, but we can get an approximate value using what we know about perfect squares. So what we do know, that the square root of 2 is in between the square root of 4 and the square root of 1, right? Because 1 is less than 2 and 4 is bigger than 2. And we do know that the square root of 1 is 1. The square root of 4 is 2. So if this is true, then the square root of 2 has to be between 1 and 2. Now, where exactly between 1 and 2? Well, not exactly sure. We can use what we know about math to figure it out a little bit here. 2 is closer to 1 than it is to 4. That's true. So we're going to come up with some decimals between 1 and 2 that are a little bit closer to 1, like 1.3, 1.4, 1.5. Whichever of these values squared is closest to 2, that's going to be a good approximation, at least to one decimal place for the square root of 2. So 1.3 squared is 1.69, 1.4 squared, 1.96, 2.25. Well, 2 is in between these two values, pretty close to 1.4, so we could say that the square root of 2 is between 1.4 and 1.5, and that means we know that 1.4, at least to one decimal place, is a good approximation. We can even go to a second decimal place just to be sure. So 2 is a lot closer to 1.96 than it was 2.25, so we're going to try to 100th place. 1.41 squared, 0.42 squared, 1.43 squared. Get my notes out, be very helpful. 1.41 squared is approximately 1.988. 1.42 is 2.016. Well, 2 is between these two numbers. It's a little bit closer to 1.41. So that's my estimation. Turn off your phone! It's a classroom. Come on. How rude. You know, just, you try and you try.
Private.
A private number. Not even going to have a name. Just kidding, it's all right.
Call from
All right, let me get back to my notes. We're going to go back to, now looking at the square root of 14. Okay, we're going to, for this one, we'll just approximate to one decimal place. But again, square root of 14. What two perfect squares are going to sandwich 14? Well, I know, the square root of 9 and the square root of 16. There'll be one larger, one smaller. And that means that this is between 3 and 4. So notice we 3 point something. 3 point what though? Well, again, we're going to kind of do the same process we did over here. We're going to look at some decimals and see which decimal is closest to 14 when we square it. So we're going to use 3.6, 3.7, 3.8. Seem some good options. See which one we're closer to. Very well. 3.6 squared is 12.96. 3.7 squared is 13.69. 3.8 squared is 14.44. Which one of those is closest? 3.7. It's the closest value, so the square root of 14 is approximately 3.7. We can do this to one or two decimal places, so maybe we can actually estimate it without needing a calculator to be attached to. So that's one thing we can use with irrational numbers. Now we're going to look at comparing some rational and irrational numbers in just a second. But first, we got a little break, and we'll be right back. Again, as always, here to support the video. Even though it's his birthday, Anthony here, appreciate it. Ross, Nelson, Rebecca, coming to show up, learning a little math with you guys today, because everybody knows math, most important subject. I mean, I'm not bragging, but I mean, it's a little braggadocious. I'm okay with that. But they're here. Thank y'all. All right, we got now is a list here of 3 numbers, here a list of 4 numbers, written in a random order. And what we're going to do is rewrite them in order from smallest to largest. Now, sometimes it can be simple. If I just had the numbers like they're all integers, it'd be really easy to see. But here I've got the square root of 20, pi, and 4/3. We've got 2 irrational numbers and 1 rational number. So we're going to have to be able to come up with estimates. We're going to come up with approximations at least to try and get us started. Well, one I know, pi is approximately 3.14. It's not exact, but it's an approximate value. 4/3 we do know is 1.3 repeating. So at least starting off, we know 4/3 is smaller than pi. The question is about the square root of 20. Kind of like what we did before. What number that's a perfect square is less than 20, and what's a perfect square greater than 20? We know that 16 is smaller than 20, and the square root of 16 is 4. Which means that the square root of 20 is somewhere between 4 and 5. Well, do we have to know the exact value of the square root of 20 to know that it's the largest of these 3 values? No, of course not. If we rewrite this order, it's 4/3 pi square root of 20. Even though we don't know the exact value of pi, or the exact value of the square root of 20, we at least rearrange it that way. Okay. Now coming over here to our second set, we've got 4 terms here now. 10.5, the square root of 100, the square root of 123, and 9.9. Well, knowing this, the square root of 100, even though it's written as a radical, we know 100 is a perfect square. And that value is 10. And if this is 10, this has got to be bigger than 10. That means 9.9 has got to be the smallest of these values. Questions about the square root of 123. Well, again, kind of using what we did just a second ago. I know that the square root of 23 has got to be bigger than the square root of 121, which is 11. Which means that the square root of 123 is between 11 and 12. Well, that makes that the biggest number here. We know that 10.5 is bigger than 10. So again, we can rearrange these and write them in order from smallest to biggest or largest to smallest. Depending on what we're asked, even though we don't know exact values for each of these or for some of the values, we still can use what we know about irrational numbers and how to estimate them to come up with an order. Okay? So we'll be right back at the end of the video. We're done for today. We'll get a little more tomorrow, though.
Many months later.
Again, another day. We're back. All week long we'll have videos, thankfully, as long as my computer does not break again. Fingers crossed. Knock on wood. Not going to happen. It's not going to happen. No way. Right? Anyway, looking forward to the rest of the videos this week. Again, if you have any questions on topics or things you want us to go over or some of these videos, please email me. Let me know. Some of the teacher of the universe right here helping you out with this math. We'll see y'all next time.